Hello, everybody. Welcome to our discussion on SuperSTAC. Thank you all so much for coming today. We're super excited to chat with you about SuperSTAC, which is really thinking about scaling stack efficiently. So we're going to get into that in just a minute. Thanks for coming. I'm Denis Willett. I'm a software engineer here at the North Carolina Institute for Climate Studies.
Uh,
Yashasya?
yep. Hello, everyone. My name is Yashasya Shah, and I'm a climate data analyst at North Carolina Institute for Climate Studies. Uh,
So we're super excited to chat with you today about thinking about scaling SuperSTAC and scaling Stack in general and what it takes to actually do that efficiently. So today we're going to be talking a little bit about the background, sort of why we're talking about this today, the motivation, and then go into thinking about the building blocks, the building components of Stack catalogs, and then how we scale Stack catalogs, why we're talking about it, and thinking about what it actually takes to run Stack at scale. This is helpful for us, but also we were asked to kind of talk about this in the context of scaling Stack at different organizations and potentially how to do this in an efficient manner. So let's dive in and chat about the background a little bit. Not too long ago at ESIP, there was the STAC Summit where we were asked to imagine a world where there was this global SuperSTAC catalog where stack collections were globally searchable. It contained all open data across all cloud providers and had this standardized API for accessing and searching the data. This is a great idea. It really goes to speaking towards improving data accessibility and discoverability. And at the STAC Summit, we started chatting with AWS Open Data, Radiant Earth. Thank you so much for the organization here and this conference, and also chatting with Development Seed. And we started actually thinking about what it would take to actually do this at scale, and if we could put together some sort of prototype for benchmarking what it would take to run this, the costs and the investment it would take to run this at scale for organizations. And the reason why we started talking about this in this group and started forming this collaboration, which we really appreciate the support from these different groups, is because there's a really good case study out there in the NOAA Open Data Dissemination Program. Many of you are probably familiar with this program. This is a program run through NOAA that makes all of NOAA environmental data publicly available on the three major public clouds across Amazon Web Services, Microsoft Azure, and Google Cloud Platform. And we at NKICS started talking with this group about using Nod as a prototype to understand what it takes to actually run Nod at scale and to be able to benchmark some of these costs so we can understand what organizations and what our organization might need to do to scale this efficiently. And the reason that we were involved in this is because NKICS, through the Cooperative Institute for Satellite Earth System Studies, is the data broker for NOAA. We're the ones that manage the NOAA Open Data Dissemination Program, and we currently manage over 64 petabytes of NOAA environmental data across all three public clouds and support over a petabyte of access a day and billions of requests per day on this platform. The reason why we thought that Nod might be a really good case study prototype for looking at a SuperSTAC type deployment and benchmarking these costs is because of the breadth and depth and diversity of Nod data sets. The quote is all the data from the bottom of the ocean to the surface of the sun, and we really have all of these data available via the Nod platform. We have bathymetry data from the oceans. We have space weather data. We have weather model data, climate data. We also have a tremendous amount of satellite data, genomic data as well, all on the cloud, publicly and freely accessible at the links below and on the cloud service providers. So we really thought this would be a really good case study for understanding what it would take to scale stack catalogs across Nod. And just to give you an idea of kind of the scale that we're talking about, here we have on the left some of the top 5, not only most popular, but some of the largest data sets on Nod as well, satellite data sets and weather models as well. The delta day is the increase in number of objects on object store per day for these specific data sets. And then the totals you see here, 800 million for GOES is the current total number of objects that we have on object store on the cloud. These numbers are just for one cloud service provider, in particular AWS. These are replicated across the other cloud service providers. So the total that we manage is multiples of this. If we look not only at these data sets, but also then across all of the data sets that Nod has on the cloud, we as the data broker currently have over 10 billion objects across the different data sets on these cloud service platforms. And this is increasing at a rate of approximately 25 million new objects per day. If you do the math, doubling time is a little bit under a year for this. It's increasing quite rapidly. So this is a little bit about the background and why we think Nod serves as a good prototype for looking at benchmarking how the cost involved and investment involved in actually scaling STAC. Let's talk about building STAC.
Okay, so let's talk about building STAC. There are three different phases. The first one is the granule phase, where we'll develop the granule mod like with the help of STAC packages. The second is the pipeline phase, where we'll automate the process of granule development and send it to the database. And third one is the access phase, where we'll make a solution to make it publicly accessible to people. So, in terms of all the three phases, we were very fortunate that because of the great community and the people present over here, we had packages for all the three of the phases, and we were able to create a stack pipeline for ourselves. So, in granule phase, we created our granule, we created a JSON object and send it to the stack pipeline. And in terms of, we'll talk more about scaling. So in terms of scaling stack, we have a granule phase where we have a lot of stack tool packages. Thanks to the great community, we had stack tool packages for most of our data sets, but for major data sets, which are kind of small, we don't really have a lot of stack tool packages. Now, it might be possible that this packages might exist, but it's not publicly available. So to develop this particular packages, we'll definitely need some domain expertise. Now, in terms of Node, we have approximately 300 datasets, and we have this stack tool packages for close to 5% of the datasets. But for the majority of the datasets, we really don't have packages. So to develop these packages will require at least one full-time employee who will be working on generating this stack tool packages and who will have domain expertise and developer expertise for this. Now, this was it for scaling the granule part. Now let's talk about scaling the pipeline part. So for the current version, we have a event-driven pipeline setup, thanks to development seat for providing us the infrastructure as a code for the current pipeline. The current pipeline is completely serverless because it is based on AWS Lambda. It is extremely efficient for a small number of pipelines. So like if we have a small influx of data, it is efficient. But when we talk about scale and more number of data sets, let's see how the benchmarking looks like. So in terms of benchmarking, we are estimating that it requires 20 cents to $1 per day for one data set, depending on the daily influx of data and size of the data. In terms of monthly cost, it would be close to $6 to $30 per data set. And if we do it for all the Node dataset, that would be approximately $2,000 to $10,000. Now let's take a rough approximate to $5,000. And just to add on things, this is just the daily data and the benchmarking for daily data. We are not considering historical data and conversion of those particular data. Now let's move on to find solution how we can decrease the cost. So one of the solution which I feel is providing a streaming platform. We feel that if we have like a Kinesis or Kafka based platform, so that we don't really need to have event driven pipelines for individual data sets, and we can have a common streaming platform for all the data set, that would definitely reduce the cost. One another solution is having a batch processing sort of a solution with spot market, so that we don't really have. So if we don't want to have an event-driven solution or a real-time solution, we probably have a batch processing solution, which might cause delay in generating the packages, but it will definitely reduce the cost. We feel that implementing either of the solution can definitely reduce the cost from $5,000 to $1,500 per month for the entire node pipeline. Uh, that was it. Now let's talk about how we'll access the data.
So in terms of access, we're very happy to be able to leverage EO API. Thank you again for DevSeed for making this deployable and available to us. This is a really performant solution built on some really stable technology in terms of PostgreSQL database with pgstack, APIs, et cetera, kind of built on top of that for the EO API. It works mainly out of the box, but it does have some management overhead. Currently, this is definitely the best option right now. But to run it at the scale for Nod, we're looking at somewhere we estimate between a 5 and 10K per month to actually run this at Nod scale across the data sets that we currently have. The other part of this is that running this at scale, at Nod scale, would require significant ongoing involvement of developers, both for tuning and for maintenance and for just basically keeping the system running, based on benchmarks and also talking with other people who have done these sorts of things at scale. We're estimating 1 or 2 developers to that would need to be continued to work on this. Other options that we're currently exploring, and we're super excited to talk to other people at this conference about in the meet and greet as well, is GeoParquet on object storage and ice chunk. We think that combinations of both of these and combining them with STAC would both solve some of the accessibility issues, but also on terms of the infrastructure side and serving them. Because when we're able to use object storage in terms of providing the STAC information in a publicly available way, we can build it and leverage the existing node infrastructure, excuse me, on object store, which already has the relationships in place and also obviates a lot of the ongoing management and is able to be managed at scale with a small team. That being said, one of the main caveats here is that there's still a lot of ongoing API work needed to actually make this work at scale and integrate seamlessly with the current UIs that are out there. So we've talked a little bit about the background and motivation for trying to understand benchmarking what it takes to run STAC at scale, both for our organization, but also broadly, and to think about how the different components of building STAC, scaling STAC, actually go into running STAC at scale. And the goal of bringing this to you all has a couple of objectives. One is we wanted to bring this information out to kind of think about what it would take to run something like a global SuperSTAC catalog at scale in a sustainable manner for the community. Hoping to get feedback from all of you on other options and the options that we presented here for making it more efficient. And then also thinking about actually implementing this at Nod, for example, for prototyping it and using this as a basis for moving forward, hopefully enhance data accessibility and discovery moving on into the future. We really thank you all for coming. Super excited to chat with you more now and then also later on in the conference today. We are happy to take questions. We have approximately 3 minutes available for questions, so please put them in the chat. We'll stop screen sharing here and we'll be happy to answer those. Thank you so very much.
Looks like Tyler Erickson asked a question.
Cool.
What is
so Tyler Erickson
breakdown of EO API costs, database versus Tyler services, etc.?
Cool. So that is a great question for DevSeed. I recommend you ask them. We can't answer that breakdown. We were primarily focused on the database aspect and the PG stack implementation. Basically having the data there and having it accessible in the database and then served up through the API. We were less concerned about the tiling aspect of things, but that is a great question. It looks like there is another question. What is spot market? Spot market refers to cloud service providers' pricing options where certain compute is priced differently depending on its availability and how ephemeral it is. Spot instances of AWS, that's correct. Cool. Question from Jonathan Rush. Have you run into scalability issues of PG stack yet? Do you think with continued tuning you can avoid them? So this is the thing, Jonathan. We think continued tuning can continue to improve the process, but because of the way our organization is run at Nod and us as a data broker for Nod, we tend to try to avoid ongoing management investments and ongoing management costs. And the short answer is, yes, we think tuning can continue to improve performance, but we would really like to put a system together that doesn't require ongoing human input to make it both more sustainable, but also to bring down the cost. So that's kind of the short answer to your question. Happy to chat more about that either now or later as well. Cool, and thank you very much, Chris, not only for the support here, but also for putting the link to spot pricing on AWS. That's what we were referring to. Other cloud service providers have similar offerings for pricing their compute as well. There was a question from Siddharth. Have you given a thought to stack GeoParquet? I believe Parquet with some table format on top will be more affordable. We are very excited to dive into that more, but the short answer is yes. That's what we were discussing at the end and having stack GeoParquet on object storage. We think that that option, because it fits well with the current Node infrastructure and the scalability of object store, could be a very good option there. Cool. Well, to give everybody time to jump, I think those were most of the questions that I've been able to pick up on in the chat. Thank you all very much for coming for the questions. We really appreciate it, and we'll chat more later. Thank you.